awak. Awak yang tu lah. Jangan lupa subscribe channel kita. Tanda sokongan. Terima kasih.
Assalamualaikum and hi everyone. Welcome back to my channel. So sebelum kita mula, saya ingin mohon maaf sekiranya suara saya kurang jelas bagi video kali ini. Sebab minggu ni saya kehilangan suara Okay. So for this video, we are going to discuss 3 extra examples on subtopic 2.1, which is capacitance and capacitor in series and parallel. We are going to discuss how to find the total or equivalent capacitance in a series circuit and in a parallel circuit. Okay, so we also discuss about the voltage across each capacitor and the amount of charge stored by each capacitor in series and parallel combination. Okay, so here is the overview about capacitor, where capacitor is a device that is capable of storing electric charges or electric potential energy. Okay, so this is the symbol for capacitor in a circuit. Alright, and next, the equation of a capacitance, where capacitance is measurement of the ability of capacitor to store charges. Okay, here we have C is equal to Q over V, where this is the ratio of the charge on either plate to the potential difference between them. Alright, so Q, the charge that's stored by a capacitor, can be calculated by this equation, which is Q equal to CV. And the unit, okay, remember to all students, when you answer a question in this subtopic, so the unit for the capacitance of a capacitor should be in farad. Please leave your answer in farad, okay, in your exam. Okay, Q is directly proportional with V when the value of the capacitance is constant. Okay, and the greater the capacitance of a capacitor, the more charge is required. Okay, means that if the capacitance of a capacitor is bigger, means the capacitor can store more charge compared to the another capacitor. Okay, here we have 3 informations that you must know about capacitors that combine in series. Okay, here we have 3 capacitors and we label as C1, C2 and C3. Okay, so when you find the total charge in this circuit, where Q total is equal to C total times the voltage, okay, the voltage supplied to the circuit. Okay, so the magnitude of the charge on each plate is the same, means that after you calculate the total charge, and the total charge is equal to, for example, the total charge is equal to 2 microcoulomb, means that for capacitors in series, the charge that across Q1 should be equal to the total charge. So let's say the total charge is 2 microcoulomb, means that Q1 also 2 microcoulomb, Q2 also 2 microcoulomb, and Q3 also 2 microcoulomb. Okay, but if you want to calculate the potential difference across each capacitor, and we have C1, C2 and C3, you can see here, so the equation of V1, where V1 is the voltage that across capacitor 1, and the equation is Q1 over C1. Okay, and you must know that for capacitors in series, the total voltage across each capacitor is equal to the voltage that's supplied to the circuit. Okay, here we have V1 plus V2 plus V3. Okay, let's see. Okay, we have voltage here is 10. Okay, here is 10. So V1, let's say we put V1 as 2 volt. Okay, after calculation, we got V1 is equal to 2 volt. And V2, let's say we got V2 is equal to 3 volt. Alright, so 2 plus 3 is 5, right? So means that for voltage across C3 is equal to 10 minus 2 minus 3. And V3 automatically equal to 5 volt. Okay, kalau you nak kira pun boleh lah. V3 is equal to Q3 over C3. Kejap lagi kita buat example, you akan nampak. Okay, and how to calculate the total capacitance in a series combination? Okay, so we have this equation. If we have a resistance in a parallel combination, so in order to calculate the total resistance in that combination, that circuit. So the equation is 1 over R equal to 1 over R1 plus 1 over R2. Okay, so dia terbalik dengan capacitor. Okay, so all the yellow box is very important in order to answer questions that related to capacitors in series and parallel correctly. Okay, so this is the diagram of capacitors that combine in parallel. Okay, so you can see here. Okay, so when the current flow from here, okay, and enters this junction, what happened to the current? The current will split into two parts. Okay, and then the current move to here, and at this junction the current also separate into two parts. If you can see here, when the current can split into two paths, okay, means that the amount of current that flow through C1 and C2 and C3 is not the equal current. Okay, so we can say that all the capacitors in this combination as the parallel combination. Okay, so we also can calculate what is the total capacitance of a capacitors that combine in parallel, and the equation is equal to, so C1 plus C2 plus C3, okay, and so on. And how about the voltage that across each capacitors that combine in parallel? Okay, if here we have 10 volt, automatically the voltage that across C1 is equal to 10 volt, and also V2 is equal to 10 volt, and V3 is also equal to 10 volt. Okay, you must know that when the capacitors that combine in parallel, V that supplied to the circuit is equal to V1, equal to V2, and equal to V3. Okay, so let's say we have calculated the total capacitance in the circuit. We can directly calculate what is the total charge in this circuit. Alright, where Q total is equal to C total times the voltage that's supplied to the circuit. Okay, so here we have Q total, okay, is equal to Q1 plus Q2 plus Q3. Means that the charge that's stored by capacitor 1 plus the charge that's stored by capacitor 2 plus charge that's stored by capacitor 3 is equal to the total charge Q. Okay, terbalik dengan series tadi, the total charge yang kita kira for the whole circuit is equal to Q1, is equal to Q2, and is equal to Q3. Okay, alright, so here is the equation of the energy stored in a charged capacitor. As we know, when a switch in a circuit is closed, means that we switch on the switch. Okay, what happened? The charge begin to accumulate on the plates here. Okay, and here the charge will be stored in these capacitors, and we can calculate what is the total work required to increase the accumulated charge from 0 to certain amount of charge, which is Q. Okay, so after the derivation, we have 3 equations here, but I suggest to you just remember one equation only. Okay, for example here, you have U is equal to half CV squared. So when you know that C is equal to QV, okay, C is equal to QV, and you try to substitute here, Q is equal to CV, and C is equal to Q over V. So when you substitute here, C is equal to Q over V, and you try to simplify this equation, okay, you will get another equation of U in terms of Q and V. So here U is equal to half QV. Okay, so tak apa, jangan risau. So let's move to example number 1. Okay, example number 1. So here we have a circuit and combination of the capacitors. So we have 4 capacitors here, and the question asks us to find the total capacitance and then calculate the charge in each capacitors and the voltage across each of them. Okay, and then calculate the energy stored in C3. Okay, so first of all, look at this circuit. Okay, so you can see here for C2 and C3. So here is C2 and here is C3. So when we have current that flow through this circuit, okay, when the current reach the junction here, so the current will split into 2 parts, here and here. So you can see here that the current that flow through C2 and C3 is not the same amount of current. Okay, kenapa? Okay, bila sampai junction ini, okay, and then the current split into two paths. So you can see here, okay, the current that passed to C3, let's say I use another color, okay. Let's say the current that passed through C3 is the purple color, okay, and let's say I use yellow, and the current that passed through C2 is the yellow one, okay. Kalau awak tengok color berbeza, maknanya the amount of current that passed through C2 and C3 is not the same, okay, so they are parallel. Alright, okay, so you can see here we have parallel between C2 and C3. Okay, so when we try to combine, okay, so look at here, we have 100 volt and C1, and this is combination between 2 and 3, and another capacitor here, C4. So C1, okay, so make sure you label so that you can reduce your mistake. So C23 here, and this is C4. Okay, alright, so now we need to calculate what is C23. So here we know that this is 10 microfarad, and here is 20 microfarad, and how about this one, C23? Okay, and then finally we can find what is the total capacitance here. Okay, so C1, 2, 3, 4, or we can write as C total or C equivalent for the circuit. Okay, so now, so let's try to calculate what is C23. So C2 and C3 are in parallel. Okay, so they are in parallel. Therefore, C23 is equal to C2 plus C3. Okay, and it's equal to 15 micro plus 5 micro, and it's equal to 20 microfarad. Okay, please make sure in your exam, in calculation, please include this symbol for the micro. Okay, kalau tak nak letak micro tu, you kena letak times exponent -6. Okay, kalau you tulis, in case you jawab exam, you tulis sini 15, oh sorry. Okay, in case dalam exam you tulis sini 15 plus 5 and it's equal to 20 microfarad. Tiba-tiba saja sini 20 microfarad. So this is wrong. Okay, konsep dia akan salah dekat situ. Okay, jadi yang saya highlightkan dengan warna kuning tu, you mesti tu tulis. Okay, alright, so it's equal to 20 microfarad. Therefore, C23 here is equal to 20 microfarad. Okay, 20 microfarad here. So now we want to calculate the C total, where it's between C1 to C1, C2 3, and C4, and they are in series. So bila awak tulis macam ini, okay, you already know that when C1, C2, 3, and C4 are in series, means that, okay, the total charge is equal to Q1 is equal to Q23, and it's equal to Q4 because they are in series. Okay, but for this one, for C2 and C3, when they are in parallel, you must know that V23 is equal to V2 is equal to V3. Ini konsep yang awak kena ingat sebelum masuk exam, sebab kita tak beri yang ini. Okay, so itu yang you kena tahu. Sebab tu you kena tahu dia parallel ataupun series. Okay, so now let's calculate what is the total capacitance in the circuit. So I will write C total because they are in series. So 1 over C total equal to 1 over C1 plus 1 over C23 plus 1 over C4. Okay, ini pun ramai yang akan buat mistake selalunya. Bila final calculation, dia terlupa ini adalah 1 over C total, bukan C total. Okay, so 1 over C1, so C1 is equal to 10 micro, jangan lupa masukkan, plus 1 over 20 microfarad. Okay, and plus C4 is also 20. Okay, Okay, so 1 over C total. So this is 1 over C total and it's equal to 2 exponent 5 farad. Okay, therefore, okay, jangan lupa C total 2 times exponent 5 is not C total. It's 1 over C total. Therefore, C total is equal to, okay, 1 over 2 times 10 power of 5. Boleh? Okay, and it's equal to 5 microfarad. Okay, so C total is equal to 5 microfarad. So this is the first answer lah for part A. Okay, make sure bila you jawab dalam exam, you letak number. Okay, so you nak jawab A, you letak number A lah. Okay, numbering. Okay, 1A contoh. So ini jawapan dia. Okay, so kita dah dapat. Okay, next we want to calculate the charge in each capacitor. Okay, so for B, so as we know that C total is equal to 5 microfarad and this is C total tadi kita tahu dia adalah C1, C2, 3 and C4 and they are in series. Okay, so we can find Q total and it's equal to C total times V. Okay, so C total is equal to 5 microfarad and times the voltage supplied to the circuit is 100 volt. Alright, and Q total is equal to 5 exponent negative 4 coulomb. Alright, so ini adalah total charge, Q total. Okay, so since they are in series, therefore Q total is equal to Q1 is equal to Q23 is equal to Q4. Okay, so sekarang kita nampak sini kita dah boleh buat untuk Q4 and Q1. So jawapan akhir dia kita boleh tulis lah. Okay, and tulis balik Q1 is equal to, so Q1 is equal to 5 exponent negative 4 coulomb. Okay, and Q4 is equal to 5 exponent negative 4 coulomb. So this is the answer. Tapi kita baru cari charge 1 and charge 4. So we need to calculate what is the charge across capacitor 2 and capacitor 3. Okay. Okay, so jangan keliru, don't be confused. Okay, for Q23, so ini bukan Q2. Ini bukan Q2. This is not Q2. So don't be confused, Q23 is not Q2 ataupun Q3. Dia adalah Q23. Okay, Q23 is the total charge stored by 2 and 3. Okay, so jangan keliru So bukan Q2 ataupun Q3. Okay, now I want to calculate what is the voltage across C1 and C4. Since here we have value for Q1 and Q4. Okay, so we can calculate V1 is equal to Q1 over C1. Okay, and V2 equal to Q2. And V4 is equal to Q4 over C4. Okay, so we can calculate Q1 is equal to, so Q1 is equal to 5 exponent negative 4 and then we have C1 is 10 micro. Okay, so finally V1 kita dapat jawapan seterusnya 50 volt. Okay, and for V4, so we can substitute here and C4 is 20 and finally V4 is equal to 25 volt. Alright, so now we can proceed. Okay, so we actually can find V23. Okay, so since C23, C1 and C4 are in series, okay, therefore V total equal to V1 plus V23 plus V4 sebab they are in series, right? Okay, so V total is 100, V1 is 50 plus V23 kita tak tahu, okay, plus V4 is 25. Okay, and finally V23 is equal to 25 volt. Okay, so look at here, since V23, okay, ask yourself, V23 is combination between V2 and V3, right? And they are in parallel. Ini yang you kena tahu, siapa parallel, siapa series. Sebab kita nak gunakan kita punya information about the charge across each capacitor tu sama ke ataupun dia total. So you kena tahu parallel ataupun series. So since V2 and V3 are in parallel, therefore you can write V23 is equal to V2 is equal to V3. So final answer, okay, you can write your final answer. V2 is equal to 25 volt. V3 also equal to 25 volt. Okay, so sekarang dah ada V2 and V3. Now we can calculate what is the charge that across Q2, which is C2V2, and Q3 is C3V3. Okay, so we can substitute. Okay, C2 is 15 micro. Okay, times, okay, kalau you tulis micro, jangan lupa bila tekan calculator, you kena masukkan power of -6 tu. Okay, okay, 25. So the answer of Q2 is 3.75 exponent -4 coulomb. Okay, ataupun you nak tulis 375 microcoulomb. So this is the answer. And how about Q3? Tak muat kat sini, saya nak tulis kat bawah lah. So Q3 is equal to C3V3. Okay, and C3 is equal to 5 micro. Masukkan. So masa tekan calculator pun mesti tekan So V3 is equal to 25. Okay, and Q3 is equal to 1.25 exponent -4. Alright, coulomb. Atau you nak tulis in terms of 125 microcoulomb pun betul. Okay, so sekarang kita dah jawab semula. Kita dah ada Q2, Q3, V2, V3. Okay, and then kita ada, tadi kita dah buat V1, V4 and Q1 and Q4. Okay, so dalam exam kalau you rasa you nak senaraikan final answer pun boleh. Macam ni kan, you nak final answer, takut nak senarkan pemeriksa kan, bersepahkan jawapan awak kan. Okay, you boleh tulis lah final answer you berapa, ada apa tadi kan, buatlah, tulis semua, tak ada masalah. Okay, and part B, we want to calculate what is the energy stored in C3. Okay, so part B, so U3, because we want to calculate energy stored in C3, so half C3V3 squared. Okay, we can just substitute where C3 is 5 exponent -6 and V3 is 25 squared. Okay, and the unit jangan lupa 1.56 times 10 power of -3 joule. Okay, so inilah jawapannya. Okay, finish example 1. Let's proceed to example number 2. Okay, for example number 2, so we have 3 capacitors which are C1 100 microfarad, C2 is 200 microfarad, and then we have C3 is 300 microfarad. Given that VAB is equal to 8 volt, and calculate the charge on each capacitor and the potential difference across each capacitor, and then calculate the potential difference between points A and D. So before we calculate the charge on each capacitor, so we need to calculate first what is the total capacitance in the circuit. Okay, so you can see here we have a junction. Okay, so let's draw the flow of current. So here is the flow of current, and when the current reach the junction, so what happened to the current? The current will split into 2 parts. Okay, so we have the turquoise color, and then this is the purple one. Okay, means that C1 and C2 are parallel. Okay, so we can calculate here where C1 and C2 are parallel. So we can write C12 is equal to C1 plus C2. Therefore, C12 is equal to 100 micro plus 200 micro. And C12 is equal to 300 microfarad. Okay, remember again, I will remind you that in your calculation, you must substitute this unit. Okay, kalau tak nak letak unit micro, you letak exponent -6. Okay, mesti letak. Kalau tak letak, you akan salah lah dekat situ part gantian nanti Okay, look at here now. After we combine C1 and C2, so we have C12 and then here is C3. And this is A and this is B. So C12 is equal to 300 microfarad and C3 is equal to 300 microfarad. And you can see here that C12 and C3 are in series. Okay, so now we can write the total C123 atau you nak tulis C total, tak ada masalah. So it's equal to 1 over C12 plus 1 over C3. Okay, so C12, 1 over C12, tadi kita dah kira 300 microfarad. Okay, so it's 1 over 300 micro plus 1 over 300 micro. Okay, so this is 1 over C123. Okay, so remember this is 1 over C123. Therefore, C123 kira betul-betul so C123 is 1.5 exponent -4 farad. So now we have calculate what is the total capacitance. Therefore, we can calculate what is the Q total, where it's equal to C total times V. Okay, so this is C total and it's equal to 1.5 exponent -4 and voltage supplied to the circuit is 8 volt. Okay, and Q total is equal to 1.2 exponent -3 coulomb. Okay, and remember that Q total is the combination between C12 and C3, right? So you get here we have C12 and C3 and they are in series. So since they are in series, therefore Q total is equal to Q12 and it's equal to Q3. So daripada sini kita dah boleh kira what is Q3. Kita dah dapat jawapan lah. So Q3 is equal to 1.2 exponent -3 coulomb. Okay, so this is the first answer for Q3. So now we want to find Q1 and Q2. Okay, so I can straightly calculate first what is the V3. So V3, excuse me, tukar color. Okay, I can calculate what is V3 and it's equal to Q3 over C3. Okay, so Q3 is equal to 1.2 exponent -3 and C3 is equal to 300 exponent -6. Therefore, V3 saya dapat 4 volt. So, saya dah settle cari V3. Okay. And how about V1 and V2? Okay. So, here we can find what is V23. Okay. So, kita boleh tulis. Ini saya tulis sebab saya nak fahamkan awak ya. Since V total is equal to V12 plus V3, therefore we can calculate V12 where it's equal to V12 plus 4. Okay. And V12 is equal to 4 volt. Alright. And remember that V12, so we have V1, so remember V12 is combination between two capacitors that in parallel. So we have C1 and C2 and they are parallel. Okay, so since they are parallel, so V12 is equal to V1 is equal to V2. Okay, so kita boleh dapat teruslah jawapannya kan. So therefore V1 is equal to 4 volt and V2 also equal to 4 volt. So this is the another answer for voltage across V1 and V2. Okay, and how about Q2 and Q1? So Q1 is equal to C1 V1. Okay, and we can straightly substitute that C1 is 100 microfarad times the voltage is 4 and it's equal to, okay, so Q1 you akan dapat nilai 400 microcoulomb. Okay, so dah dapat Q1. Okay, same goes to Q2. So Q2 is equal to C2 V2. So Q2 is equal to C2 V2 and C2 is 200 micro and V2 is equal to 4 volt and it's equal to 800 microfarad. And it's equal to 800 microcoulomb. Okay. So kita dah dapat jawapan. Okay, kita dah cari V1, V2, Q1, Q2, V3 and Q3. Okay, so number C kita nak kira apa? Okay, so dalam exam kalau you nak jawab B, the potential difference across each capacitor, okay, you boleh tulislah B. So calculation as above. Ataupun you salin balik. Okay, you salin balik calculation as above ataupun you salin balik calculation tadi pun boleh. And then you tulis jawapan. Okay, macam tu. Okay, so for C, we want to calculate what is the potential difference between point A and D. Okay, so between point A and D, remember here, so we have the combination C12, okay, AB, and here D. Okay, so this is C3. So means that if we take the voltmeter, okay, we connect here. So here is the voltmeter. Alright, so what is the value that we can read from the voltmeter here? Okay, what is the potential difference between A and D? So we can calculate where VAD must equal to, okay, so this is VAD and it's actually the voltage across V12 kan. So ini adalah V12. So V12. So from the previous question, we have calculated that V12 is equal to 4 volt. Therefore, VAD is equal to 4 volt. Boleh? Kat atas ni tadi kita dah kira V12 is equal to 4 volt. Okay, so finish example number 2. Let's proceed to example number 3. Okay, example number 3. Here we have 5 capacitors in the circuit and we want to find the voltage across each capacitor and then we want to calculate the energy stored by 60 microfarad capacitor. Okay, so I want to advise you, if you have this type of question, okay, first of all, you must label all the capacitors in the circuit as C1, C2, C3 and so on. So for me, I prefer to label all the capacitors before I start my calculation. Okay, so it's easier for me to recognize, okay, that calculation is for C1 or C2 or C3. Okay, so this is C1 and this is C2 and I want to put this as C3 and I want to put this as C4 and this is C5. Okay, okay, so now look at here. So we have C4 and C5, they are in series. Why? Okay, let's draw the flow of current. So look at here. Okay, so this is the junction. So this is the junction. Okay, and current will flow through here. Means that C1 and C2, the current split means that C1 and C2 are in parallel. Okay, how about this one? after junction. Okay, you can see here that current that flow through C4 and C5 is the same current. Ada junction tak dekat sini? Ada junction? Tak ada, no junction. Okay, so current not split into two paths. Okay, C4 and C5 are in series. Okay, so when we combine C4 and C5, you can look at here. Okay, so we need to simplify. So this is in parallel. Okay, so this is C4 and C5, and this is C3 and this is C12. Okay, so you can see here. So when we draw the flow of current here, look at here, we have the flow of current that split into two paths. Okay, so now C3 and C45 are parallel. Okay, awak kena identify tu dulu, kena fahamkan tu dulu, siapa yang series, siapa yang parallel. Okay, so now we start our calculation with C45 first because they are in series. Okay, so kita tulis elok-elok lah. So you want to calculate C4 and C5 and they are in series. Okay, so since they are in series, so 1 over C45 is equal to 1 over C4 plus 1 over C5. Okay, so substitute 1 over 60 micro plus 1 over 120 micro. Okay, based on the question. Okay, so finally C45. Okay, remember this is 1 over C45. So lepas you kira yang ini, you kena terbalikkan lah 1 over answer dia berapa. So C45 is equal to 4 exponent negative 5 farad. Okay, okay, and how about C3 and C45? So C3 and C45, they are in parallel. Kita guna color lain lah. Okay, C3 and C45, so they are parallel, means that C345 is equal to C3 plus C45. Okay, so C3 berapa tu? C3 is equal to 20 micro plus, so we have 345 is 4 times 10 power of negative 5. Okay, and finally C345 is equal to 6 times exponent negative 5 farad. Okay, so finally, so after we combine C345, okay, and then we have a new circuit here, okay, new diagram, so they are in series. Okay, so C1 and this is C345. Okay, so now C total or C equivalent is equal to, because they are in series, C1 and C345, so they are in series. Okay, so since they are in series, 1 over C total, okay, equal to 1 over C1 plus 1 over C345. Okay, so we can strictly substitute where C1 is equal to 120 micro. Oh, sorry. Okay, so now let's draw the combination of all the capacitors. So here we have C12 and C12 are in series with C345. Okay, so we can write here that C12 and C345 and they are in series. Okay, so we can write C total is equal to 1 over C12 plus 1 over plus 1 over C345. Okay, so now we can substitute. So kita dah kira tadi C12 is equal to 120 microfarad. Kita kira tak tadi? Okay, oh kita tak kira. So kita boleh kira lah. Boleh kira kat sini. Okay, because they are parallel. Okay, so C1 and C2 are parallel. So C12 is equal to C1 plus C2. And 70 microfarad plus 50, and it's equal to 120 microfarad. Okay, so C12 is 120 microfarad. Plus C345 is 6 exponent negative 5. Okay, so you akan dapat C total is equal to 4 exponent negative 5 farad. Okay, but the question tak tanya pun suruh cari total capacitance. Okay, dia nak calculate the voltage across each capacitor and also the energy stored by 60 microfarad capacitor. So we want to calculate what is the voltage across C1, C2, C3, C4 and C5. Okay, so now C total. So what I want to do now, okay, I want to calculate what is the charge, the total charge. Okay, the total charge QT is equal to CTV. C total 4 exponent negative 5, and V kita, okay, soalan bagi 60 volt. Alright, so it's equal to so it's equal to 2.4 exponent negative 3 coulomb. Okay, so this is Q total. Alright, so you must look at your circuit. Okay, so Q total tadi kita buat, last kali kita buat tadi, dia adalah between Q12 and Q345, and they are in series, right? Okay, so since they are in series, means that Q total is equal to Q12 and it's equal to Q345. Okay, so berapa tadi? 2.4 exponent negative 3 coulomb. Alright, so therefore I can calculate V12. So from here I can calculate V12 is equal to Q12 over C12, because we want to find what is the voltage across each capacitor. Okay, so Q12 is equal to, okay, 2.4 tadi kita dah tengok, and total capacitance is 120 for C12. C12 is 120 microfarad. Okay, and it's equal to 20 volt. Okay, look at here. V12 is combination between C1 and C2, and they are parallel. So since they are parallel, therefore V12, okay, is equal to V1 is equal to V2. So kita dah menjawab soalan lah. Okay, so V1 is equal to 20 volt, V2 is equal to 20 volt. Okay, so kita dah dapat jawapan kita. Okay, V1 and V2. Alright, and since V1 and V2 is 20 volt, how about V345? Okay, remember, okay, V345 and okay, so since V1 and V2 are parallel, so now we want to find what is V345. Okay, remember the combination. So here we have C12 and this is C345. Okay, so if here is 60 volt and the voltage across V12 here is 20 volt. And how about V across 345? Okay, so V across 345 kita boleh kira lah. So V total, because they are in series here, so V total is equal to V12 plus V345. So 60 minus 20, sorry. So here 60 equal to 20, and this is V345. Therefore, V345 you akan dapat for 40 volt. Okay, so for V345, okay, its combination between C3 and C45, okay, and they are parallel. Therefore, V345 is equal to V3 is equal to V45. Okay, sebab dia parallel kan. So dari sini kita boleh terus dapat jawapan V3 is equal to 40 volt. So kita dah settle V3. Okay, and now we want to calculate what is the voltage across 4 and 5, right? Capacitor 4 and 5. So since I have V45, so let's use another color. Okay, so since V45 is equal to 40 juga, therefore we can calculate Q45 is equal to C45 V45. Okay, and C45 kita dah kira tadi, it's 4 exponent negative 5, and V45 is 40 volt, and then Q45 is equal to 1.6 exponent negative 3 coulomb. Okay, and remember 4 and 5 are combination between C4 and C5, and they are in series. So since they are in series, so we can write that Q45 is equal to Q4 is equal to Q5. Sebab itu you kena ingat, bila capacitor in series, siapa yang sama? Charge dia yang sama. When the capacitor is in parallel, dia punya voltage yang sama. Okay, so this is equal to 1.6 exponent negative 3 coulomb. So therefore, from here we can calculate V4 is equal to Q4 over C4, and it's equal to 1.6 exponent negative 3 over C4. C4 is equal to 60 microcoulomb, and it's equal to 26.7. Tu dekat bawah lah. Okay, and therefore V4 is equal to 26.7 volt. Okay, ni jawapan dia. And for V5, we can also calculate V5, Q5 over C5. Okay, same method, where Q5 is equal to 1.6 exponent negative 3. Okay, and C5 is equal to 120 microcoulomb. Sorry, microfarad. Therefore, V5 is equal to 13.3 volt. So kita dah jawab semua. Okay, V1, V2, V3 and V4 and V5. Okay, and next we want to calculate the stored and next we want to calculate the energy stored by 60 microfarad capacitor. Okay, iaitu merujuk kepada, kalau merujuk kepada lukisan kita tadi, okay, ia adalah merujuk kepada capacitor yang ke, inilah yang ke berapa ni, yang keempat. Okay, ini, okay, merujuk kepada C4, which is C4 is equal to 60 microfarad. Okay, so now B, ada B ke? Tak ada kan? So now for U4, it's equal to half C4 V4 squared, and it's equal to, okay, so kita boleh kira lah, 1 over 2, C4 is 60 microfarad, where V4 kita dah kira ke atas ni tadi 26.7 squared. Okay, cuba kira berapa dapat. Okay, so the final answer is equal to 0.021 joule. Unit jangan salah Okay. Okay, so kita dah habis semua example untuk subtopik kali ini. Okay, see you in the next video. Thank you for your support. So siapa yang belum like and subscribe, okay, boleh subscribe channel saya sebagai tanda sokongan. Assalamualaikum dan salam sejahtera. Teruskan berusaha, teruskan belajar. Okay, jumpa lagi.